Looking at cells, questions and answers. And the questions relate to both electrolytic and voltaic cells. The questions are based on past IB questions I've seen on past papers over many years. First two questions. Take a moment to think, and I'll put up the answers. So in question 1, how is zinc behaving in this rather complex looking voltaic cell? I'm not worried about anything else that's happening. It's the zinc I'm being questioned on. Zinc is losing electrons. My answer in blue. As the zinc loses electrons, it's oxidized. If it's oxidized, it's the reducing agent. Electrons are lost at the zinc electrode, making it the negative electrode. That brings me down to A. Second, which statement is correct when sodium chloride is electrolyzed in the liquid state? In other words, it's molten sodium chloride. Now, in the name, sodium chloride, we never mention it, but positive ions are always named first, negative ions second. Sodium ions are positive. So my sodium ions are positive. If they're positive, they will be reduced when they're discharged. That can only happen at the negative electrode. Chloride ions, named second, are negative, so will be oxidized at the positive electrode. That takes me to C. My chloride ions are attracted to the positive electrode and are oxidized. Next. So in question 3, 3 parts. Draw a label diagram to show the voltaic cell. Deduce the half equations at both anode and cathode, and show the direction of electron flow in the circuit. Here I have my diagram. 4 points. First point, I've got my half cell with iron metal in contact with iron ions in solution. Second point, I've got my copper metal in contact with copper ions in solution. I need to have the salt bridge in there. There's my third point. And I need to have connection via an external circuit, which actually is where electricity will be generated. For my half equations, well, the anode here is the site of production of electrons. That's where iron is oxidized. Half equation given. At the copper electrode, copper ions are reduced by accepting electrons sent around by the iron half cell, and my direction of electron flow showing the electrons leaving the iron half cell flowing around to the copper half cell. Which labels for the electrolytic cell are correct? Again, I'll pause for a moment. Okay, so here I'm looking at liquid sodium chloride, so molten sodium chloride. Sodium ions attracted to the negative electrode. Sodium ions must be positive. They are named first in the formula. Always have the positive ions before the negative ions. So at 1, I've got my sodium ions reduced. I'm down to C or D. At 2, the only other ion present, the chloride ions, are going to be oxidized. So again, C or D. 3 shows the external circuit, and electrons must be conducted between the electrodes by normally a wire, but a conductor. It's the ions in the electrolyte that conduct charge in 4. Choose the correct statement for the passage of electricity through molten potassium chloride. Again, I'll pause to give you time to think. And here what we have is, it's molten potassium chloride. I'm melting the potassium chloride down and passing electricity through it. I'm not obtaining electrical energy as in A. So, electrical energy is used to make a non-spontaneous reaction occur. A is out. For B, potassium ions are oxidized. They cannot be. Potassium ions are positive. Chloride ions are negative. Potassium ions will be reduced. B is no good. I'm now down to my chloride ions. Well, my chloride ions will lose their electrons. In order to do so, they'll be attracted to the positive anode, the site of electron production. Takes me to C. What happens at the negative electrode in the two different types of cell? Pausing for a moment again. Okay, so here, in a voltaic cell, producing volts. In a voltaic cell, electrons are lost as it forms ions. Now, that will happen at the negative electrode. Electrons lost there, that's oxidation. A or C. In the negative electrode in an electrolytic cell, let me actually show all the answer. Cations are reduced. They're attracted to the negative cathode and are reduced, giving me A. Finally, which statement describes how current is conducted in an electrolytic cell? Again, I'll pause. Well, electrons travel through the external circuit to get to the ions that are going to be reduced. They travel around the external circuit, but in the electrolyte, I've only got ions that can do my conducting. So, it's electrons that travel just through the external circuit and ions that actually do the moving in the electrolyte. I hope that was useful. If it was, please hit like. Please subscribe to be informed of more content.